Hello viewers, welcome to video number 118 of the channel MALACHEMPHILIC. And video number 118 is the 58th episode of Chemical Thermodynamics, where the topic is MCQ on, that is multiple choice questions on Gibbs free energy graph and equilibrium constant. So let's start. Our first question is, under what situation log K or ln K, ln is equal to 2.303 log we know, versus 1 by t plot is as follows. So here you have seen that this curve is, 1 minute. So this is the plot, that is log K versus 1 by t. Okay, and this plot is, it is a straight line passing through origin. So under what condition? 4 options are given, right? So we know that delta G naught is equal to minus RT ln equilibrium constant, right? Again, so we can write that RT ln or minus RT ln equilibrium constant, that is equal to delta G0. Delta G0 means standard free energy change, that is equal to delta H standard enthalpy change minus T delta S standard entropy change. So we can write ln K is equal to this minus delta H naught divided by this R into this is 1 by T, then this is plus, you have taken minus this side. So delta S naught, T will get cancelled, 1 by T and T, and here it is R. So therefore what we can write, log K, that is equal to minus delta H naught divided by 2.303 R into 1 by T plus delta S naught divided by 2.303 R, right? So now you see this equation, this is the equation for y is equal to mx. That means this part will not be there. This constant part will not be there. Okay. So when this constant part is not there, that means what we can write, constant part is not there. So, sorry. So what we can write, that here this one is equal to, this should be 0. This should be 0 means, that means your delta S naught should be is equal to 0. And this should be positive, y is equal to mx, so this should be positive. Positive means delta H0 must be negative, that is less than 0. If it is negative, then negative it will become positive. So here you will see the option, this option delta H0 less than 0, delta H0 is equal to 0. So this is the correct answer. Okay. Now let's see the second one. Identify the correct plot for ln K or log K versus 1 by T under the situation. Here they have given the situation. Delta H0 less than 0 and delta H0 greater than 0. Just now we have seen that this our log K, just now we have derived log K is equal to minus delta H0 by 2.303 R into 1 by t and then plus delta S0 divided by 2.303 R, right? Now delta H0 less than 0, that means negative. So if it is negative, 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 positive, and this part is 0. Delta is 0 greater than 0, greater than 0. Greater than 0 means this part is positive. So this is also positive, this part also positive. So it is taking the form of y is equal to mx plus c. Y is equal to mx plus c means it is a straight line with intercept on y-axis. That means this is the correct answer. Next one, under what situation log k or ln k versus 1 by t plot is like this? Now once again we'll write down the equation. So log k is equal to this minus delta H0 by 2.303 R into 1 by t, then plus delta S0 by 2.303 R. Okay. Now, it is a straight line parallel to this x-axis. Right. That means there is parallel to the x-axis means the slope will be 0. The slope will not be 0. Slope will not be there. Slope will be 0. That means here it is delta H0 must be is equal to 0. And so only it is a constant term. Whatever with the 1 by t, it is becoming constant and in the positive direction. It is positive direction. So delta S must be positive. Okay. So delta S naught must be positive. Right. So delta H0, that means standard enthalpy change is 0 and delta is not greater than 0, that is positive. So this is the correct option. Now fourth question. Identify the correct plot for ln k or log k versus 1 by t under the situation delta H greater than 0, delta H not greater than 0 and delta is not greater than 0. So once again you write down this one, log k is equal to minus delta H0 by 2.303 R into 1 by t plus delta S0 divided by 2.303 R. Right? Now, delta H greater than 0, that means it is positive. It is positive means positive, negative. Here this part will become negative. Slope will be, this part will become negative. And delta is greater than 0. Greater than 0 means this part will be your positive. Right? So, it is taking the form of y is equal to minus mx plus c. Minus mx, that means y is equal to mx plus c, that is straight line with intercept on y-axis but slope is negative. So, this will be the correct plot. Then this fifth one. Delta H0 of the reaction represented by the given plot is. Now, look at here. Here, it is making this line, curve is making the angle 45 degree. They have given. So, once again, our log k is equal to, that is minus delta H naught divided by 2.303 R into 1 by t, okay, plus delta S0 divided by 2.303 R, right? Now, here 45 degrees, so slope will be your tan 45 degree Angle is 45 degrees. Slope will be tan dy by dx. So tan 45 degree will be equal to 1. And here this is the plot of, this is y, this is y, this is m, okay, this is x, this is c. Y is equal to mx plus c. And slope is this one. The slope is, that is 1. Okay, slope is equal to here, slope is equal to minus delta H naught divided by 2.303. R is universal gas constant whose value in calorie is 2 calorie. 2, that is equal to 1. That is the slope. So, our delta H naught, that will be equal to minus 2.303 into 2. So, it is coming as minus 4.606 calorie. So, minus 4.606, this is the correct answer. Now, sixth question. Correct set of parameters corresponds to the given plot is. Okay. Now, here also free energy versus extent of reaction. This is the plot, right? Now here we know that delta G0 standard free energy change of the reaction that is equal to free energy of formation of this product, okay, minus free energies of this your reactant, okay, standard free energy, right? Now here you see this product has less energy, free energy than reactant. So product minus reactant, this will be negative. So delta G0 reaction, that will be negative or less than 0, right? Fine. Now look at this curve. Here the equilibrium is close to the product. Equilibrium is close to the product. We know that this equilibrium constant K is equal to what is the concentration of this product minus concentration of the reactant. So when it is close to the product, that means this numerator will be more, means here K must be greater than 1. And this reaction, product is favored. Okay, equilibrium position, product is favored, right? So, what is the condition? G is less than 0, K is greater than 1, equilibrium position, products favored. So, this is the correct answer, right? Next one. So, now similar things. Here, delta G0, that will be is equal to, here also product is more, so G0 product minus G0 reactant, so this is positive, product is more here from the graph, so this is positive. Positive means or it is greater than 0, right? Now, this equilibrium position is close to the reactant. So, close to the reactant means this K, which is this concentration of the product by concentration of the reactant, it is close to the reactant. That means reactant concentration is more. Reactant concentration is more means, so therefore here K must be less than 1, right? K is less than 1 and here it is reactant favored. Equilibrium is position is reactant favored. So what is the condition? Condition is this, here we have seen that delta G0 greater than 0, and K must be less than 1. So here option B, delta G0 greater than 0, K less than 1, equilibrium position, reactant favored. So this is the set of parameters. Now next one, correct set of parameters. Here you see delta G0, that is equal to G0 product, standard free energy of product minus standard free energy of the reactant, and here both are same. So this is equal to 0, right? Okay. So this is equal to 0. We know that this delta G0 is equal to minus RT ln K. So your ln K that will be is equal to minus delta G0 divided by RT. Now delta G0 here it is 0. So 0 by RT. So this is equal to 0. ln K is equal to 0. Therefore here K must be is equal to 1. So K1 delta G0 is 0. Where it is delta G0 is 0, K is equal to 1, and equilibrium position equally favored. That means product and reactants are equally in the same distance from the equilibrium position. So where it is so correct answer is, so therefore our correct answer is this one, delta G0 0, K is equal to 1. Okay. Now this is the Gibbs free energy graph with various parameters. Okay, and here it is. So G is equal to H minus Ts, and we know that dG is equal to VdP minus SdT. So if we differentiate with respect to temperature at constant pressure, it is equal to minus S. So negative of entropy. That means with temperature, if temperature increases, Gibbs free energy will decrease for gas, liquid and solid. Now the decrease is sharp for gas because in the gaseous state entropy will be more. Okay, randomness will be more. So decrease in temperature, this random decrease in the randomness will be more. So it is sharply decreasing, whereas liquid, this entropy is less compared to gas. So here also with the increase in temperature, the decrease of entropy is less compared to this gas. Therefore, with increase in temperature, decrease in free energy is less for liquid compared to gas. And here solid entropy is still less compared to liquid. So here entropy is decreasing. So decrease in entropy will be, means compared to gas, it will be not so sharp. So therefore decrease in free energy with respect to temperature at constant pressure, it will be less in solid compared to liquid and gas. And then this one with pressure. Now dG is equal to VdP minus SdT. So dou G by dou P at constant temperature is equal to volume. Volume is a positive quantity. So with increase in pressure, Gibbs free energy increases. Okay, and the pressure has little effect on liquid. So increase in Gibbs free energy is less compared to gas. Solid has still less effect, means pressure has less effect. So decrease in free energy is still less. Hope you have understood. Thank you.